Okay, part D. If the object is initially at the point 0, 6, find its position function s of t, and use s to check your answers to parts B and C. So as we mentioned before, the velocity is the first derivative of the position. So that means that the position can be recovered by integrating the velocity. But remember, this indefinite integral, this antiderivative, gives us an entire family of functions. I need to pin down exactly which one I want. So that's this. This is the initial condition. I'm told that the object is moving along the y-axis, and this tells me that we're initially up here at 0, 6. So the initial position on the y-axis is 6. So s of t is the integral of s prime of t dt, which is the integral of v of t dt, which is the integral of 3t squared minus 2t minus 1 dt. This is the same antiderivative I've had before, so it's t cubed minus t squared minus t, but since there's no definite limits, I know that all these antiderivatives are off by a constant. So to pin down this constant, I use my initial condition. So initial means t equals 0. And the position we care about here is 6 units up on the y-axis. So I know that s of 0 is 6. So I plug in t equals 0 to the left-hand side, I'm supposed to get 6. I plug in 0 on the right-hand side, I think you're going to read the writing on the wall here, I get c equals 6. So putting this together, I know that s of t is t cubed minus t squared minus t plus 6. So how can I use this to check what's happening up here? Well, let's look at the path of this object. It starts up at 6. That's at t equals 0. When I integrated from 0 to 2, I look at s of 2, and I get 2 cubed minus 2 squared minus 2 plus 6. We've seen this before. 8 minus 4 minus 2 is 2. 2 plus 6 is 8. So when t equals 2, I'm up here at 8. And so what's the net displacement here? Well, I started at 0. When t is 0, I'm at 6. T at 2, I'm up at 8. So it's a positive 2 displacement. I'm 2 meters above where I used to be. So that checks part B. How do I check part C? Remember, in part C, I had to break this up. I had to break it up at t equals 1. So let's look at what s of 1 is. S of 1 is 1 cubed minus 1 squared minus 1 plus 6. I get 1 minus 1 minus 1 plus 6. That gives me 5. So at t equals 1, I'm at 5. And what was important about t equals 1? That's when the velocity changed from down to up. So the path of this object, I start at 6, I head down to 5. And then at 5, I turn around and I start heading back up. So 6 to 5 is a 1 unit distance. Then I go from 5 back up to 8. That's a 3 units distance. You add those together, you get 4 units. So that checks part C. That'll do it for quiz 17.